Assalamualaikum warahmatullahi wabarakatuh. So let's proceed to the second learning outcome in chapter 11, 11.2 Young's modulus. So we are going to define Young's modulus and we're going to look at the mathematical relation of Young's modulus. Okay, so Young's modulus first is defined as the ratio between stress or tensile stress to the tensile strain if the proportionality limit has not been exceeded. Okay, so as simple as we just divide stress, which is sigma, and strain, which is epsilon, and then we can calculate Young's modulus. Okay, so we can, in other words, we can say that Young's modulus is actually a property of a material to show that how easily it is being stretched, it is being deformed, or maybe it's being bended. Okay, so every material will have different value of Young's modulus to show the property of that material, how stiffness the material is in response to the stress or force. Okay, so this value of Young's modulus is only applicable to the material as long as the limit of proportionality is not exceeded. So meaning here dia mesti obey Hooke's law tau. Hooke's law where force dengan extension is directly proportional kan? Okay, and then dalam graph untuk stress versus strain juga region elastic deformation tu adalah where Hooke's law is obey, di mana kita ada straight line. Kalau masih ingat lah, okay, graph untuk stress versus strain, kita ada first part dia straight line, okay, until point A if I'm not mistaken. So this is the region where Hooke's law is obey. So dekat sini kita boleh this value of Young's modulus is applicable for that material. Even kita boleh kira Young's modulus ni menggunakan graph ni nanti. Okay, so first let's look at the formula of Young's modulus. Okay, so Young's modulus denoted as symbol capital Y is ratio between stress to strain. Dan kita tahu apa unit bagi stress adalah Pascal dan no unit bagi epsilon ataupun strain. So meaning Young's modulus dia ada unit of Pascal or unit for stress lah, Nm negative 2. Okay, so kalau kita expand lagi formula untuk stress dan juga strain, kita ada stress is equals to force perpendicular to the cross-sectional area, force over area, and then divided with extension over original length. Okay, kita rearrange the formula sampailah kita dapat formula Y equals to FL naught over EA. So kesemua kuantiti ni masih lagi applicable lah, seperti definition untuk stress dan definition untuk strain. Okay, so Young's modulus also a scalar quantity. Kat sini. Okay, sebab stress scalar quantity, even strain pun scalar quantity. Okay, so ini yang saya cakap tadi. Kita boleh kira Young's modulus daripada stress strain graph by calculating the gradient of this graph. Okay, tetapi kita hanya boleh kira gradient sepanjang along the line of OE ni. Okay, so the gradient represent Young's modulus of graph of stress versus strain. Okay, so stress bahagi strain kan, cara kita kira gradient pun Y bahagi X kan. So eventually kita akan dapatlah amount of Young's modulus. Tetapi hanya untuk straight line region je, elastic, di mana material tu hanya obey Hooke's law. Okay, so Young's modulus dia macam saya cakap tadi, it measures the rigidity of the material, the stiffness of the material, how strong the material, how easily it is being deformed. So even though dalam formula Young's modulus ni kita ada apa namanya tu length. Okay, kalau perasan dia ada length, tetapi Young's modulus ni hanya bergantung kepada property of that material sahaja. Okay, so dia tak bergantung kepada length. So imagine you have two copper wire with different length. The first one is 5 cm and the second one is 10 cm. So ada 5 cm, ada 10 cm. Jadi both are made from copper because both are copper wire. Jadi both has the same value of Young's modulus because it is made from the same material regardless of the length. Okey, jadi tak kisahlah panjangnya berapa, tetapi yang modulus dia orang masih lagi sama sebab material dia adalah sama. Okey? Okey, so dalam tabelnya menunjukkan sum of the material with their respective Young modulus. So, kita boleh imagine, kita boleh fikir logik yang material yang ada high value of Young modulus is stronger compared to material yang ada lower value of Young modulus. Okay, so kalau dalam table ni kita tengok steel tu quite high, 20 exponent 10 Pascal. Okay, menunjukkan more force is needed to deform steel. Okay, compared to material yang ada yang modulus yang lebih rendah. Okay. Okay, now let's look at the relation between K and Young modulus for a wire. Apa relation antara K dengan Young modulus dan apa itu K? K ni actually force constant ataupun selalunya kita gunakan word spring constant yang ada dalam formula Hooke's law, which is F equals to negative KE ataupun negative KX. X atau E itu adalah extension. Okay, so daripada formula untuk Young modulus yang kita derive ke atas tadi, FL0 over AE, kita masukkan force Hooke's law dalam formula ini. So, end up kita akan dapat KE L0 AE. So, kita cancel out the E. So, end up kita dapat Y equals to K L0 over A. Rearrange untuk dapatkan relation ni lah. So, relation yang sama. Just nak menunjukkan relation antara K dan juga Young modulus. So, apa relation force constant dan juga Young modulus? Imagine K ni as a spring constant. Spring yang ada high value of K, maksudnya dia sangatlah stiff. Dia sangatlah stiff. Susah sangat untuk kita compress ataupun untuk kita stretch. Kita perlukan relatively a very high force, a very greater stress to extend ataupun compress the spring. So, benda yang sama dalam case ni. So, greater K means Young modulus dia lebih tinggi untuk material tu. So, it means that material is more stiffer. Okay. So, apa maksud stiffer material ni? So, usually stiffer material ni dia tends to maintain its size and shape even kita apply load ataupun force. Okay, dia akan tend to maintain its shape and size, its original length, unless the force is very, very high. Okay. So, stiffer also means stronger inner atomic bonding. Imagine you want to break the atomic bonding. So, means you need a very large force to break the bond. Okay, so itu maksud stiffer material. So, just nak menunjukkan relation between K and Y. So, it's actually directly proportional. Okay, so let's look at example 2 here. A wire with length 1 meter is lengthened by 0.6 mm when a load with a mass 20 kg is hung on it. So, wire is placed vertically with a length of 1 meter is lengthened. So, maksudnya dia ada extension of 0.6 mm. So, that will be L0, that is extension. Ini adalah mass. Kemudian apa yang dia beritahu lagi adalah diameter of the wire is 2 mm. Calculate the Young modulus. So, wire ada, ni wire. Kemudian ada load of 20 kg. Okay, so wire usually dalam bentuk silinder lah. Okay. Okay, ada load 20 kg. Lepas tu dia minta kita kira Young modulus. So, kita just gunakan formula. Boleh guna stress over strain. Maksudnya kita cari stress terlebih dahulu ataupun kita cari strain kemudian. Atau kita just simply gunakan formula yang kita dah derive tadi. FL0 over AE. So, F adalah force yang perpendicular to the cross-sectional area. So, kalau kita gunakan force ini, make sure kita punya cross-sectional area adalah circle ni lah. Okay, so with the diameter of 2 mm. So, kita kena carilah cross-sectional area of a circle. Okay. So, force kita adalah 20 kg. Force equals to mg lah. 20 times with 9.81. Okay. Force kita mestilah equals to mg. So, basically dia adalah weight lah. Okay. So, your weight equals to 20 times with 9.81. 81. Okay, L0 is given, which is 1 meter over area. So the formula of cross-sectional area of a circle is pi, and the radius is 1 millimeter. Okay, exponent negative 3 square, because it's pi r square times with extension is 0.6 pun juga mili. Okay, so kita boleh cari yang modulus kat sini dengan unit dia, sama unit dengan stress. Ataupun kita boleh juga tulis dia sebagai nm and nm negative 2. So, question 2. The force constant of the wire. So, force constant of the wire negative KE lah. So, force sama dengan weight. K yang kita nak cari, extension is 0.6. So, we can simply calculate K kita berapa. Dan check lah apa unit bagi force divided by extension. So, dia akan jadi N M negative 1. Okay? Logiknya macam tu lah. Okay? Alright. I think itu sahaja untuk yang modulus. Untuk first part ni, kita akan continue next video untuk next learning outcome. Okay, thank you.